It is 3:50. Okay. Again, we have to close by 6:30. Okay. So what we discussed last class is about a networking. What is network? What is networking? What is internetwork? What is internetworking? Different type of networks, LAN, CAN, MAN, WAN kind of stuff about it. What is intranet? What is internet? What is default gateway? What is an NIC and Ethernet cards? Different Ethernet cards. And in a Ethernet cards, what are the names are there? And about NIC, MAC address, and difference between about a MAC address, how to check MAC address and IP address part. Point is how to check MAC address. Different type of cables, coaxial cable, copper twisted pair cable, fiber optical cables, and those kind of stuff. Okay.
Sir, can you please highlight the majorly asked question in interview?
Mm. So we'll see that. Different topologies, networking topologies. Okay. Up to topologies, we are discussed. The left or part is not a left or part is. Then the next part is. So we are discussing about the devices, networking devices. First one is today's date 02/12/2022. Yes, we are in a networking. So devices means networking devices only. Okay, but so when you are saying that these networking devices, compulsory say like networking devices. What are those devices which is help you to communicate between the your main devices? Okay, like a computers. So one of the important devices hub. Next one is switch, router, modem. I'm adding few more in between. Repeater.
Hello.
Tell me. So what is a firewall? What is CSU, DSU? What is TCE, DTE? Yeah. What is firewall? What is CSU, DSU? What is DTE, TCE? What is VPN? There's a few kind of stuff is also there. Frequently asked questions, highlightation. Guys, I am teaching not general theory and then questions not separated. What are important, that much only I'm telling. Okay. What to highlight here? Tell me about fiber optical cables. Already highlighted points only. I remove lot of things. What is there to highlight here? Okay. Don't mind about it. It is what I'm trying to say is. So please. I will highlight here. In the networking devices, you need a hub, compulsory, switches, router, and modem. So these four are very important in the networking devices. Remaining are just the names. Maybe there is just things, but still you don't mind about it much. Okay, so very important, very basic level. Hubs, switches, routers, and modems are important. So what is this hub? Here is a small introduction is there. So guys, you can see networking devices. So you want to go through a single shot kind of stuff. Okay, you want to go through with a very simple and a single short sentences. So then you can. Okay, Nitin came. Okay, so each networking device with a single sentences. Hub. Hub is used in LAN communication. Hub is a device but used in LAN communication. Hub is used for a small networks. Repeater. Repeat the signal to communicate long distances. Switch. We use for a LAN communication both small and large networks. Switch is additionally know how to learn MAC address of a PC. Bridge. Bridge is usually software based bridging between two networks, two NICs kind of stuff. Soft router, router or router. Router tell how to reach destination. How to reach destination. It works in both LAN and WAN. It is internetworking device. Modem connects you to internet. We are getting internet through the modem because of modem is making connected to your ISP. So then we are getting internet through using telephone cable or a fiber optical cables. So simple not only. So one by one we'll see. Guys, hub or a repeater. Hub. Initially we say hub. Repeater we'll discuss, but first one is hub. Hub is a non-intelligent device. It does not contain any a separate circuit for a processing related kind of stuff. It does not contain any that kind of stuff here. It is a broadcast type. So I will explain by removing something. It is a non-intelligent device. It does not understand. It does not understand my IP address or a MAC address. Okay. So I said broadcast, right? So this is a hub and this is start topology means devices connected to a hub. Okay. So this is the device is hub device. Look at here, guys. A want to send a packet to B. In hub, what will happen? A send a packet to B. A is the source, B is the destination. Packet is sent to the hub and packet is sent to the B and packet is also sent to the C. Same packet is also sent to the D and E and F. Means what happened? You want to send a packet to A to B, but all other devices also got a same packet. For example, you want to send a packet from C to D. C send a packet to hub. Hub will be the packet sent to a B and F and E and D and A. Okay, so they will it send a packet to like this. Now it is C to D communication. D accept the packet, remaining will drop the packet. Okay. Next A to B. A to B. So A send a packet to B. B will accept the packet. C, D, E, F will drop the packet. So my point is, guys, you want to send a packet from one device to another device, but hub don't understand where is your destination. It forward the packet to everyone in the network. Understand, guys? So hub broadcasts packets to everyone in the network. It broadcasts the packets to every device in the network. It does not understand IP address MAC. It does not know who is the source, who is destination. It does not know. It take it and send it on. Okay, we use for LAN communication, suitable for a small networks. This hub is also called as we specify as a layer 1 device. As per OSA layers, OSA having 7 layers. Okay, as per OSA layer, it is hub we call it as a layer 1 device, which is physical device. Because of these broadcast, guys, because of these broadcast, number of collisions will occur. The so much of data packet loss is there. Number of collisions are occurs, the packet data loss is there. Okay. You can see this is a repeater. Repeater is generally wide repeaters also there. You see, this is the repeater. Guys, what are the wire we are using generally? UTP, STP cables, right? This UTP or STP cable, you'll see it is a weak signal. Okay, so what it will, this repeater will do, it repeat the signal again. Okay, sorry. UTP STP cables will support up to a particular distance. For example, 100 Mbps. So 100 meters it will support. Generally, it will support 100 meters. What about after 100 meters? So signal is almost all weak. So what we do, we use a repeater to repeat the signal from one place to other place. Okay. So it is repeat the signal. It don't boost the signal. Okay. It repeats the signal. It don't boost the signal. So it receives the signal and repeat and send. Hub act like a repeater. Sometimes you can use a hub as a repeater. I'm giving an example is repeater is a Wi-Fi extender. What is this Wi-Fi extender kind of stuff? What is this Wi-Fi extender? So if you are having your Wi-Fi router in some place, okay, but you are from there to your PC, it is lot of distance is there. For example, in our office, okay, when we are taking a class in generally in starting, so it is very slow. Means how much I'm speaking, but the it is people are not receiving the voice because of lot of voice disturbance is there that time. So I realize I check the internet connectivity. I'm getting very small signal, okay, and very less internet connectivity. So I try with the connect with the cable. Now I'm getting good speed internet connection. Okay. So what is this? Use of this Wi-Fi extender kind of stuff. You have a router which is very low signal, but you have you are in a different distance. You want to get connected, so you can use Wi-Fi extender. Through Wi-Fi extender, you get full signal, and we can able to connect. This is hub. The hub picture it is. This is how hub is look like. Next one is switch. What is a switch? So when you type in Google, it is a networking switch. If you
Sir,
put a switch, you will get a mechanical switch, or turn on or off switch only. You tell me.
sir, hub and hub and repeater both are physical layer device. So what is difference between hub and repeater?
Hub is actually, if you, I think we didn't see properly repeater. Okay. So hub is a, this is a
Connecting
repeater,
device.
right? Yeah, it will connect multiple devices as a LAN communication. But repeater is between
Amplifier.
this. See, it is a signal and it is strong signal. So signal strength is weakened, and repeater repeat the signal and forward the signal again. Okay. So that is a repeat.
It's like a amplifier, right?
Amplifier amplify the signal. Okay, good. Amplifier amplifies weak signal become strong signal. Amplifier amplify the signal. But here it does not change the any strength of the cable. It is so it is same signal. It will receive a same signal and repeat the signal only. That's it. It won't boost the signal or amplify the signal. But both are good. Original repeater picture will be there like this. See like this. So from this device to device, 200 meters distance is there. So use a repeater for repeating the signal. Okay. Okay, so switch is an intelligent device. Okay, it maintain MAC address table. What is this MAC address table? We'll see. Okay, each port of the switch has a fixed bandwidth, that is waste point. It is, of course, switch is an intelligent device. It understand and learn MAC address. Okay, this half duplex, full duplex, no one knows correctly. That is different kind of stuff. Switch is a intelligent device. It will understand a MAC address of a devices. Okay, so we use a switch for LAN communication. It is a layer 2 device. Hub is a layer 1 device. Switch is a layer 2 device. Hub and switches both we use LAN communication. Both we use for a star topology. Both we use for a star topology. Okay. And switch can understand MAC address of a connected devices. So switch also used for large number of devices connected. So you can connect it to a switch network. So large number of devices we can connect it. Number of collisions are less, so less packet data loss. So lesser the collisions happens at a switch level. There is a two functions of a switch. One is MAC address learning and forwarding. Okay. So guys, switch is a layer 2 device, but there is a layer 3 switches are there. What is this layer 3 switches? Okay, what is this layer 3 switches? Okay, it is function as a both switch as well as a router. For example, you want to enter VLAN routing, then you can do it with the L3 switches. So L3 switches operates at L3 protocol like a IP address and the stuff, and L2 switches. Mine is not at all working. Of course, there is an explanation is there, but before that one, switch. Which is also used for a star topology. Which is also used in star topology. Okay, all are silent today. So all are these same pictures. This is look like a hub as well as a switch also. Hub and switches both are look like same, but this is definitely a switch. How I know? Because number of ports, number of connectivity is there. Again, once again, we'll see, guys. Switch is an intelligent device. It is maintain MAC address table. It learn MAC addresses. MAC address learning is there. It is a used for LAN communication. It is a layer 2 device. Okay, data. So sorry, layer 2 device. It is a data link layer. Switch is also used for both small and large networks. Also there. So in general, is a lot of devices we can able to connect to a single switch. Okay.
Sir, what is floating and unicast?
That is, yeah, I will tell. Guys, in a hub, 1 second, guys. Just 1 minute. Lot of distances. Sorry. Yeah, just we'll see what is search to. That is that unicast kind of stuff. Then we'll take a small 5 minutes or 10 minutes break. Okay. Okay. So this is a this time it is a switch. Both are look like same because it is a same start topology. Both devices, if in case small size switch, small size hub, both are look like same only. Both are used for a star topologies. Both are using for a star topologies. Okay. But in this one, in a hub, what happened? A want to send a packet to B, but the packet is sent to everyone connected in the network. It is same in the switch also, but in a only in initial time only. Okay. So I want to put these port numbers. If you see real switch, can you see each switch port having a number? Each switch port. Any closer photos are there? We know. Somewhat it is look like closer. So each port having a port number. Okay. So what will happen here? So this switch port, for example, 1, 2, 3, 4, 5, 6, 7, 8. It is a 8 port switch it is. So 1, 2, 3, 4, 5, 6, 7, 8. Now you want to send a packet to B. Initially, the switch also don't understand where is the B. So it broadcasts to everyone. Broadcast to everyone. It broadcasts to everyone. But what is this switch will do? What is this switch will do? It create a MAC table, MAC address table. Okay, that is also called as MAT, MAC address table. How it is? Port number 1, A's MAC address, APC MAC address. It captures. Okay. Now, for example, this is a CPC want to communicate D, C to D communication. But packets is sending to everyone because It knows is PC MAC address which is at port number 1. But now does not know where is D with the D's MAC address. So C send a packet. So C's MAC address it will be mapped to port number 3. The port number is 3. Same way, when these devices are connected and start communicating, so what it will do, it will put it like this. Like a third port, no. 3 is at C, 2 is a BPC, okay, and fifth one is EPC, sixth one FPC, seventh one DPC. Okay. So what happened? I guess still I'm slow. Yesterday I become faster, so I need some boosting now. Okay. This is the last point, guys. So I created a MAC address table now. MAC address table is created. Now FPC want to send a packet to BPC. Now where is B's MAC address? B MAC address is here, and B's is connected to port number 2. B is connected to port number 2. So F2B. Okay. B is connected to 2. So packet is go to the switch C, which is what is the destination MAC address. It is a B's MAC address. B's MAC address is mapped at port number 2 and it is given to B directly. Means initially it is broadcast, but once it is learned the MAC address of the devices and map it to the respective port number. So while it is communicating next time, it do unicasting. Okay, so that is the point. I will add more points are there. So last time I added in a previous batch, so I'm adding. Guys, hub is broadcast domain. This is not very thing. So single. Actually, remember hub broadcast packet to everyone in the network. Okay, hub is a single broadcast domain and a single collision domain. Next, so it is do unicast. Switch broadcast packets to everyone in net to everyone in network initially. Switch broadcast packet to everyone initially. Okay, so later, or we can say once MAC address table created, Easy it is. Later, unicast packets using MAC address okay works with unicast means that is okay guys, very simple. Hub is a non-intelligent device, switch is an intelligent device. Hub don't understand MAC address or IP address kind of stuff, but switch can understand MAC address of its devices and it maps the device MAC address to switch port number. So that is called a MAC address table. So hub broadcast packets to everyone in the network. Means A want to send a packet to B, but the packet is also sent to others in the network. Okay. So in a switch, it is initially broadcast to everyone, but later it is become unicast. Okay, initially it is broadcast packet to everyone, but later it is unicast packets using MAC address table. Okay, switches a single broadcast domain means so the entire switch is a single broadcast. Entire switches is the broadcasting part. It is a multi-collision domain. So collisions won't occur at switch level. Collisions at port level. So multi-collision domain. Okay, multi-collision domain. So switch hub is always broadcast the packets to everyone connected to that device. Okay, switch is not like that. So initially it is broadcast, but once it is learn the MAC address of the devices, okay, connected is this MAC address of device is connected. It create a MAC address table by port name, switch port number, and a MAC address of the devices. Okay, switch is also used for single and large networks, and hub and switches both are LAN communication purpose. Okay, and hub is a layer 1 device, physical layer. Switch is a layer 2 device, is a data link layer.
Sir,
Tell me.
so I have a question like, sir, you have mentioned over that switch is a multi-collision
Collision.
domain. Sir, can you help me understand that why is that? Because switch does not broadcast to every device in a network. That hub does, right? Then how multiple collisions will be occurring at that point?
Yeah. So that is a multi-collision domain, not multiple collisions. But I will tell. So what is this
Okay.
broadcast domain and collision domain kind of stuff? First of all, hub. We know it is broadcast to everyone. But what is the limit of broadcast? Within the hub, it will broadcast. Right? The broadcast will happen within the hub connected only. It does not extend it to others. Same goes for a switch. The broadcast within the here switch only. Okay. Both side the broadcast is within the switch only. Single collision domain. So I have a devices are connected in the hub. It always do broadcast, right? So A to B, for example, and it will also send to A, B, C, D, E, F kind of stuff. And similar time, if another device is trying to send, again, for example, C to D, C to D, C send a packet to D, but it is sent to C, D, A, B, E, F kind of stuff. Okay, so simultaneously, because of this communication, okay, this type of communication simultaneously, number of collisions increases. Okay, so number of collisions will happen more random, so more data packet loss. So again and again you have to send same packet because of packet data loss, so you cannot able to get proper. So more number of devices used, more number of collisions throughout this hub. But switches understand, once it is understand unicasting. Okay, so very simple guys. A is device is there, B device is there. A send a packet to B, and C is also sending packet to B. What happened here? At port level, there is a collision. Similarly, same time, there is a DPC sending a packet to A. Okay, A is also sending a packet to C. So what happened? Collision will occur. Okay, so like each and every port number 1, APC, for APC it is exit, and A is receive a packet from different other devices, right? So that is the collisions occurs at a port level. That's why it is called a multi-collision domain. Okay.
Okay, sir. Yeah, understood. Thank you, sir.
Okay, guys. Next two devices are there. One is a router, another one is a modem. Mainly two devices, router and modem. So we'll discuss that one. Take a small 10 minutes break. Have a tea or coffee. Please don't sleep.